So when we are writing a program to given number is even number or odd number or prime number. Okay. So we are writing for program for that one. For example, I give a number 5. Okay. I save that number into variable n. Okay. Now I want to find that number is the number 5 is even number or odd number or prime number. Generally, how can you tell that number 5 is even number or odd number or prime number? 5, how can you tell even number it is even number or odd number? How can you tell?
Divisible by 2 gives 0. It is even.
Only divisible by 2. So for example, if you 5 by 2, that is even number. 5 by 2, how, what is the output? So if any number,
1.
so that is not correct. So what we need to tell, if any number divided by 2 and the remainder value is 0, then that number is even number. Otherwise if the number is divided by 2 and divided by 3 and the remainder is 0, then that is odd number. So I already told you, for remainder, what is the operator we are using? The operator percentage. So if 5% 2 equal to 0, so if we divide by 2, if the remainder value is 0, then 5 is even. So how can we write in the program? So here we write the logic. First we write the if statements. So conditional if n percentage, this is called modulus, okay, a remainder equal to 0, then percentage 2. If the number module 2 percentage 2 equal to 0, then that means if the number n divided by 2, the remainder value is 0, then n is
Even.
even. Given number is even, right? No, right. No, other condition. Now if n divided by 3 and the module equal 0, then so that means if a number divided by 3 and the remainder equal to 0, then that number is odd number. That we print given number is odd. Okay, what is the prime number logic? How can you tell a number is prime number?
If number it has 2 factors, 1 and itself.
That means if a number is divided by 1 or only itself is give the remainder 0, then that is
prime.
that is prime number. So what we need is, for example, if n it's by itself is remainder equal to 0, or n by 1 remainder equal to 0, and it must not be other number. Let's take by 2. It must not be 0. Any other number, not 2. If you take any other number, it must not be 0, right? So here 3 conditions we are checking. First condition, only itself, if the number itself divisible and remainder is 0, or if the number is by 1 and sorry here and. So here three conditions are checking. What are the 3 conditions? the number itself, the remainder is 0. The number divided by 1 and the remainder is 0, and the number with other number. Let's take example 2. It must not be 0. If it becomes 0, that is not the prime number. Only if the first two conditions. If any other number divided by 2 or 3, so any other number is not by. So here what we need to do? So prime number logic, how can we tell? Not only 2, right? You can not only, we need to write not but also 3, right? Then how can you tell prime number logic? How can you write? Okay, first I will explain prime number logic in next video. So to this in this video I will explain the given number is even number or the given number is odd number. For example, if you give number 22, okay, then 22 is the even number or odd number?
Even.
So practice. So what is the output? Given number is even. If I give 23 here, then it must be odd number, right? 23 is even number or odd number?
Prime number.
Prime number. That's why it's not print even. It's not print even number. It's not print the odd number. If I give the 27, then it must be odd number, right? Now, how to check the given number is prime number? We need to write that logic. Okay. So you understand the logic for the even number and odd number?
Yes.
Now we need to write how to check the prime number. Okay. Let's take. Let's take the number. Okay. Now I'm writing the program for the prime number logic. If n is equal to 1, if n is 1, automatically that is the prime. 1 is the prime number, right? Prime. Right? 1 is
2,
prime.
3, 5. 1 is not a prime.
So 1 is not a prime. So then it must be greater than 1, right?
Yes.
It must be 0 is not a prime number, right? Hello?
Yes.
1 is not the prime number.
Prime number.
So now we need to check greater than 1, right?
Yes.
Okay. Now if n is greater than, how we need to check? We need to write a for loop. So from take where I equal to 2. Okay, that next number must be less than n. Up to we need to. So here from number 2 to the number below the given number. For example, I given the number 7. I am checking the 7 is prime number or not. So what we need to the prime number logic is 1 and itself. So remove the 1 and 7. What is the other numbers we need to check? We need to check with the other numbers between the 1 and 7. Okay. We need to check with the 2. We need to check the 3, 4, 5, 6. If the 2, if the given number the between the 1 and that number, if it is divisible the 0, then that is not the prime. Otherwise, this is prime. So what we are checking here? if n divided by I is equal to 0, then it is that. Let's take a variable like prime. It's a prime. Prime is true. If any number divided by true, then prime becomes false. Okay, so final output is prime. So final output is if prime, then you print in the prime number. That means here we are taking one variable prime number, prime variable. So let's take the given number is prime is true. Now what we are checking, I'm taking the numbers between 1 and that number, taking each number and divided with that number. If the remainder equal to 0, then it's not the prime number, right? For example, if take the number 7, so I'm checking between the 1 and 7, so I'm taking 2 divided by 7. If it is 7 divided by 2, the remainder is 0, it is not the prime number. 3 divided by 7, if equal to 0, if the remainder is 0, it is not the prime number. That's why I'm making the prime false. If between the if the number if any number between the 1 and is that number is not giving the remainder 0, then the obviously prime number. You understand?
Yes.
Now 27 is prime number or not?
Not a prime.
Let's check what it will print. Not prime number. If I give the 23, then
Prime.
right. Also, okay. This is the logic for the prime number and prime number logic.